All right, so hopefully you watched the last video. I was going to go ahead and do unit vector notation in this one. Again, no Pythagorean theorem. We don't want to have to mess with that. So what you're going to want to do on this one is, let's look at this. This green line right here represents your displacement. And if you recall from the other video, that can be delta x or this s with an arrow. I'm going to use the s with the arrow to really prove how it's, a vector. All right, now this is going to be your y component. That is usually recognized to be a y, and this is called a circumflex, but we can just say y hat. It's kind of like, it's the directional thing, because it's kind of like someone took this off the arrow and it just put it on his little party hat or something silly like that. So you have that, and then this of course would be your x component. And if you would have x, y, and z for 3D. Some of you will have the opportunity to do 3D. And for those who want to be engineers, and I'm probably going to ask about this if, in class, you'll see it as I, J, and K. And the reason is, of course, engineers don't know their alphabet that high. I'm just kidding. Physics teacher is supposed to be mean about engineering. I actually learned it I, J, and K. That's how the Navy did it. So anyway, and that's just kind of one of those things that's a little bit different, just depending on where you study things. So you have these three things of it. Now, let's say that this is, let's give this some numbers. Let's say this is 24 meters that way, and the other one looks like it's about twice as long. Yeah, so let's say this is 48 meters in your x direction. The way I would write that would be displacement, my displacement vector, this is my resultant vector, is going to be equal to, now what I'm about to show you is not an equation. Do not call it a formula or an equation, or I'll know you didn't do what you're supposed to do. No, this is directions. When you see what you're about to see, this means, hey, draw a triangle. Your life will be easier. Otherwise, I can have you do the Pythagorean theorem in your head or with a broken calculator. So, and this isn't like something you'd use on problems. This is something that'll just help you do interesting things like throwing beanbags or whatever. So, displacement vector, your resultant vector, doesn't have to be displacement, can be velocity, whatever, is equal to, I'm going to do an open parentheses. Let's do our x. See how this x is going in the positive direction? I'm just going to not write a positive, I'm just going to write 48x with a hat. Okay, plus, now look, see how the y is going in the negative direction? Oh, actually, so I shouldn't put plus, because it's plus negative, and hopefully you know that that is a positive. So I will put minus 24y. All right, notice I did not put the units. That's because, and close parentheses, and see the units distribute to both. So that's meters. So that's your unit vector notation. Nothing more than that. It's pretty easy. You're going to definitely need to know how to do this for tomorrow. We're going to be making maps, some of you in 3D. Quick question, and you can pause it for a minute because I'm curious. What would happen if this were 24 meters per second squared, and this were 48 meters per second squared? Well, that would be, well, that's not displacement at all. Okay, take a minute, pause it if you need to, hopefully you know. That would be, well, here, let me fix it over here. So now I'm going to change this to meters per second squared. And this would be, for your resultant, if you said acceleration, you're right. This works with acceleration, with force. But what about energy? If you said no, because energy is a scalar, you're right. So doing this tomorrow, make sure you have notes on it. And also, I'll do another video about scale.